Good morning, everyone, and thank you for joining us for today's presentation. We're going to get underway for today's presentation on Vortex Studio's hydrodynamics simulation capabilities. My name is Jean-Pierre Picard, and I'll be your host today. I'm Product Marketing Manager at CM Labs. With me on the line is Marc-Alexandre Vézina, Product Manager for Vortex Studio. Marc-Alexandre, thanks for joining us.
No problem.
So today's presentation is going to be split into a few categories because there's more than one way you can perform hydrodynamic simulation in Vortex Studio. So we're going to start by talking about the basics of simulation of rigid bodies interacting with fluids. And this is going to apply to the different options you have for hydrodynamic simulation, regardless of which one you select. Then we're going to look at the new fluid surface extension that we've introduced in Vortex Studio's latest release, 2017A, which was launched a few weeks ago. Now, this approach to hydrodynamic simulation, as we'll see, provides some basic simulation capabilities that are available in every edition of Vortex Studio. So that's going to be interesting for those of you on the line that are using Vortex Studio Essentials. Then we're going to take a deep dive into Vortex Studio's ocean component and other maritime environment simulation tools. Now, these will be available to Vortex Studio solo team and academic edition owners, but it'll be a good walkthrough of everything we have on the dynamics and visual side to create a maritime simulation, and that is if you want to do surface or even undersea simulation. And we're going to end with the Q&A period. Now, if you have any questions during the presentation, please feel free to send them our way using the right-hand side GoToWebinar interface. You'll also notice we put in a copy of today's presentation in PDF format, as well as a copy of our Vortex Studio Maritime Simulation datasheet, which includes some key points on the ocean component that we're going to be presenting later. If you have issues with audio, visuals, please let us know using the questions box. We'll do our best to help troubleshoot it from a distance. And if you have questions during the presentation, send them in there and we'll pick them up at the end of the Q&A period. We'll have a few live demonstration segments during the presentation. And as usual, this is being recorded and we will send you a copy by email following today's presentation. So you can share it with colleagues, rewatch it if you're getting started with hydrodynamic simulation Vortex Studio, or just do a quick review if you ever have questions about a specific component. Now, for those of you who are joining us and saw our webinar posted either on social media, Twitter, LinkedIn, and you're not sure what Vortex Studio is, just a quick introduction. Vortex Studio is a full simulation platform for ground and maritime equipment. So what it does, it allows you to create immersive simulations that run in real time, and it includes everything you need to go from simulation creation to deployment on a simulator, and that means easy-to-use desktop applications, an integrated visualization engine, and a physics-based dynamics engine that provides true-to-life simulation. And of course, since every single simulation project always has its specific requirements, a full-featured SDK that allows you to either complement Vortex Studio or replace different components so that you can achieve exactly what you need to deliver. Now, Vortex Studio's main advantage is that it allows you to focus on your mission. If you're building a simulator, chances are you're not in the software platform development business, you're in the simulator business. And by having a unified development environment such as Vortex Studio, you really get to focus on delivering differentiated products that your customers will purchase, and not on troubleshooting integrations that aren't really part of your core value. It also delivers true-to-life simulation because we're using a unique approach to the dynamics portion of the simulation. That is, we use physics-based approach. So we simulate individual components of vehicles and we use validated models from the engineering world and we apply this to real-time simulation. That's going to give you more realistic results that deliver better training. And as I mentioned, Vortex Studio has a very extensive SDK, and it's built on a modular architecture, so that means that you're never going to be stuck having to start from scratch with Vortex Studio. You can always extend components or swap out components based on a specific project's need without overhauling your entire simulation development workflow. Now, Vortex Studio is used in multiple industries. Today we're going to talk mostly about maritime, but it's also used in the construction industry for earth moving and lifting equipment. In fact, CM Labs has its own product line of construction training simulators, if you're familiar with the company. The main topic today is the maritime simulation capabilities. And so that could be for ship or port-based equipment. As you see here on the screen, you could be using maritime simulation for ships that are docked, and you're going to get more realistic training for port-side equipment. But you could also be doing ship deck equipment, and which is a bit more what we're going to be talking about today. And it's also used in defense, mainly for its vehicle simulation capabilities, so that is vehicles that are either tracked or wheeled. Could also be robotic systems, and the fact that we offer advanced simulation capabilities for cables as well is a big plus in that industry. The Vortex Studio is deployed worldwide, and it powers today over 1,000 simulators in 35 countries. So that makes it the de facto standard for ground vehicle and maritime equipment simulation. I mentioned different editions for Vortex Studio, so if you don't have Vortex Studio deployed quite yet, know that there is the Essential Edition that is a free edition for internal and limited commercial use. It's going to provide you what you need to get started with real-time simulation. So you'll get multi-body dynamics engine, vehicles and cable systems, although those are only for internal use, so if you're doing virtual prototyping. You can build a complete simulator with a single computer with that. If you're looking at commercializing a simulator product, we recommend going the solo or team edition, depending on the size of your development team and the scope of your project. Those come with the full simulation capabilities of Vortex Studio, including maritime environment simulation, which we'll talk about today. So today, Fluid Surface, as I mentioned, is available in Essentials Edition and obviously Solo and Team Edition, whereas the full maritime simulation will be Solo and Team Edition only. Today we're going to be using the Vortex Studio Editor, which is our desktop environment to create and validate your simulation content, and you use it to perform mechanical modeling, create scenes, as well as connect hardware controls into your different equipment. We're not going to look at the Vortex Studio Player, but the Vortex Studio Player is an application that allows you to create simulators and distribute content across a simulator and each of its display and manage the simulation itself. So this is available, but it won't be used in today's demos. All right, so let's jump into today's topic, hydrodynamic simulation in Vortex Studio. So the first thing we're going to look at is the new Fluid Surface extension. What you're seeing here is a really quick preview of what it is. Basically, it simulates either on a terrain mesh or on a planar surface. It creates the buoyancy and the flow that you configure. So it can be set up as an infinite plane, or you could select a terrain mesh to really put it into a scene. And then we're also going to spend some time talking about the ocean component. Now what that is it simulates an infinite plane of water, and it uses wind and sea scales, and these are recognized models to simulate maritime conditions. And this is something that's also going to come with integrated visuals, as you see here. So we're going to get into that a bit later, but first let's make sure that everybody understands the basics of hydrodynamic simulation. So the things that we're simulating when we do rigid body hydrodynamics, first of all, there is drag. And drag is the force that's going to be exerted by a liquid on an object that is moving in it. So, and that's going to be familiar to anybody who's ever been in water. If you're trying to run in water, for example, it's going to be a lot harder simply because the fluid you're trying to move out of the way is pushing back against you. That also applies if you're turning an object. It's just going to be a general resistance force. Next is lift. Lift is a force that is applied to push the object in a perpendicular way to the direction it's moving. So we're not necessarily talking here about the buoyancy effect, which will make objects float on the water. It's something that is going to be pushing, again, in a perpendicular way, and it's going to be affected heavily by fluid density. Next is buoyancy, and this one is going to be a property that is based on how you set it up on your object, and that is the way it will be floating upward based on how you configure it. And finally, the last one is added mass, and added mass is a bit trickier to represent visually, but think about it as the effect of all the liquid that you are displacing when you're moving. So when you're starting your movement, then this liquid is going to be pushing back against that movement, and it's going to be provide a slower acceleration. Now when you're trying to stop, you're going to have a mass of fluid that is pushing in the direction you were moving. So that will effectively slow down the deceleration. It will be longer to achieve a full stop. So that it was added masses, and these are the main physical phenomena that we are simulating with rigid body hydrodynamics. Now, what that means is that we're not doing computational fluid dynamics here. We're not simulating the flow of fluids themselves. We're simulating the interactions between rigid objects, such as a ship, amphibious vehicles, and fluids. And that's why we're not going to be looking at something such as what you see here, which is a SolidWorks simulation, which is used for engineering purposes and not necessarily for training. What we focus really here is design for ship-based equipment training, such as equipment launch and retrieval, offshore platform cranes operations, and we've talked earlier in the presentation, portside equipment as well. Now, Vortex Studio can be enhanced for full vessel simulation. Because we have a modular architecture, you can connect more advanced simulation engines. And the best example for this is, I would say, Maritime, the Maritime Research Institute Netherlands, which is using Vortex Studio, but it's using their advanced ocean simulation dynamics to power full vessel simulation. And you can see here a bit one of their simulator, which was on display at ITSEC last year. So you could be doing that with your own dynamic engine if you needed more advanced simulation capabilities for full vessel simulation. So let's jump into it. The first thing we're looking at, as I mentioned, is the fluid surface extension, which is new. It was introduced in Vortex Studio 2017. And you're going to be using that extension when you don't need waves, basically. If you don't need wave models, then all you need is to simulate drag, lift, buoyancy, and a current, then that's what you're going to use. It's going to be a lot less taxing on computing resources, and you'll be able to tie this to a terrain mesh to simulate some scenarios such as a water crossing. You don't need to simulate a full ocean with wave models if what you're doing is a small river that you're crossing with an amphibious vehicle. You could also use it for underwater only scenarios when wave models aren't necessary for the behavior of your equipment. And you could also be using it for certain littoral exercises, such as, again, you could be doing a launch and recovery if you're not needing wave models. I mentioned it's available with Vortex Studio Essentials, so that's also a great way to get started with hydrodynamic simulation in Vortex Studio. Now it's going to have a few parameters, and we're going to jump into a live demo in just a few seconds, but just so that everybody understands what we're looking at when Marc-Alexandre walks us through, the first thing you're going to set is the fluid density, and the fluid density is what it says it is, and the higher the density, the more lift you're going to get, and the harder it will be to move through the fluid. The fluid velocity allows you to set the direction of the current, the flow of the fluid. And you're going to be setting it on the X, Y, and Z axis, and that's going to affect the direction of your objects. Now, you're then going to select the fluid surface type. So if you select an infinite plane, which is the planar approach, then you can select the fluid elevation, which will define at which height compared to your scene's base grid the fluid should go. Now you could also be using a terrain mesh, which at this point you will be tying your fluid surface to a specific area that is defined by a graphics node. So I'm just going to pass the controls to Marc-Alexandre. Marc-Alexandre is going to show us how to set up a fluid surface extension. Here you go.
Thank you, GP. So for this demonstration, I built a very simple scene containing two rigid bodies, a sphere and a cube. Now this scene will be made available to people registered with this webinar. Please note that when you first open the scene, nothing will be showing. You need to activate the grid by right-clicking on the viewport and selecting the grid option. And then you click up here on Use Grid and set it to Material and Ground, apply and close it. And you will also need to right click on the eye icon and activate the geometry to make the collision body visible. Now what I did here is that I created a cube and a sphere. So let's go into the cube part. So it's a very plain 1 meter cube. So if you look at the object itself, in the property panel, you've got a tab called Geometry here. So when you click on it, you can see that the tab includes a number of selection for the collision geometry that are available. So in this case, I created a box type collision geometry. And for that box type, I've activated collision, buoyancy, drag. I haven't done the lift. I could have, but I choose not to do it. And if you have more than one collision geometry, obviously you're going to have a longer list here, and you can select what you want to have in the what you want to have active for each collision geometry. This is useful. You'll see, I'll show you a bit later on a ship. I'm using 2 collision geometry, one very detailed for the fluid interaction and one very simple for the collision detection. So it simplifies the computing. In this case, I've put a mass that's slightly under the buoyancy. And as usual, I've done my my inertia tensor with the compute inertia income. I haven't added any mass tensor, but you can see you can just select the parameter that you want to change and then just change it. If you make a mistake, you can reset it using the reset added mass button. So on the side of the collision geometry, you see that there's a field called fluid interaction. So if when I selected here, if I remove buoyancy and drag, these parameter in the collision geometry will not be visible. So this entire section will not appear. So you can adjust the center of buoyancy, the displaced volume, and set up the drag coefficient. So in this case, I've just set the drag coefficient to a number of 1 because I just want to show the effect of current on an object. I've also set up a sphere. For the sphere, I went a bit different. So again, I set up the buoyancy and drag. This guy, I let its mass at 1 kilogram, so it's a big 2 meter wide sphere, and it's just 1 kilogram, so it's very light. And I've also set it so that the displaced volume is 0. So imagine it as a mesh type material that lets water penetrate inside. So there's no displaced volume here, but there's still some drag occurring. So if we go back to our scene, I'm going to add a fluid surface to the scene. So I type fluid and I see it in the dynamics. So again, I double click on it. I could also drag it, but I like to just double click. It goes faster. So now I've got my fluid surface extension. So here on the side, I've got my fluid density. So it's standard for water. Usually you will not be touching this this parameter unless you change it to account for temperature, for example, or if you're simulating a underwater probe on the methane sea of Titan, for example, you're going to want to change the density, of course, but most of the time you're going to leave that parameter alone. Fluid velocity is to set up some current in the X, Y, and Z axis. Fluid elevation here is the Yes, second. There we go. So fluid elevation here allows me to set up the height of the fluid. So we don't have an accessory, unfortunately, for the fluid surface. So you're going to have to take my word for it. Just imagine the grid as being 1 meter lower, and that's where we are. So if we press play, so nothing much is happening, as you can see. But I can use the mouse spring to show that the objects are actually rigid body that are operating. So now we're going to raise the fluid elevation to 0, so it's now exactly flush with the grid. And now we're going to go to 1 meter, and you can see that the cube is now floating in the water. We didn't set any displaced volumes for the sphere, so it's not actually floating in the fluid surface. So if we just raise the fluid volume, you can see that it's bobbing up and down and is eventually going to stabilize as the simulation goes steady. So that's very good. So if we go back to 0 and I go back to my my sphere, for example, now this time I'm going to put a displaced volume. So let's say that we're using the true volume. So that's 2 meter wide. So that's going to be, if memory serves, 4. Let's say 4 It's close enough. Now I've put my sphere, I've given it a displaced volume, so there's a buoyancy associated with it. And I'm going to put like 5 or 6 meters of water above the fluid surface. So now when I press play, obviously these are going to rise because of the buoyancy. This one is like a balloon that's at the bottom of the pool, so if you ever tried that, you know exactly what's going to happen. So it just shoots up to the surface and starts bouncing on the surface of the water because it's very light, it's displacing a lot of volume. So it's just this little section here that's in the water, and this one is floating deeper. If we go back to the cube, and then we go back to the part, and then we put a greater mass, we recompute the inertia, and we go back to our fluid. And we're just going to move this out of the way. And then this time you can see that the cube is staying down inside the, let's just put that back on the side here. You can see that the sphere is still floating up on the surface of the water, but now the cube doesn't have enough buoyancy, so there's drag here, so it's slowly sinking to the bottom of the water. That's very good. So let's go back to the setup to the original mass that I set, so compute inertia, there we go. And let's go back to our sphere again, so we're going to put it back to our original mass, and we're going to put our displaced volume back to 0, there we go. So now my cube is floating in the water. Let's drop it a bit so that's true. And then this time we're going to put some velocity in the fluid. So I'm putting some velocity in the fluid, and you can see that the rigid body are subjected to the drag effect. So they're dragged along by the current in the fluid surface. So by doing this, in the X, Y, and Z, you have a lot of control over how you want your fluid to move, and you can represent most underwater behavior using these tools. Back to you, GP.
Thank you, Marc-Alexandre. All right, so we're going to jump back to our presentation, and what we're going to do is we're going to start talking about full maritime environment simulation. Now, Vortex Studio has what's called in the toolbox an ocean component, and that's where we're going to start when we want to do maritime environment simulation. We're going to still be talking about the same physical properties for how rigid bodies interact with the water, but the big difference is we're going to be using wave and wind models to drive surface visuals and dynamics. So we're going to add that component that at the surface that is really about an ocean type environment. Now, the ocean component provides a lot of configuration options such as depth, density. You can also control sampling resolution. We're going to talk a bit about why that is important, but you can basically simulate a lot of different scenarios based on what you need. If you're just doing surface training, then undersea conditions will not be as important, but you could do a full deployment of a remotely operated vehicle from a ship all the way down to the seabed, and then even operating it on the seabed. And the ocean component will give you the features you need for that. Now, we've looked at it in the fluid surface demo, but you need parts that include buoyancy, drag, added mass. And keep in mind, and this is really interesting when you're doing maritime simulation, is that this can include cable, and obviously, like if you're lowering equipment to the seafloor, then the interaction of cable with waves, with currents, is going to be integral to the quality of the training you're giving. Now, it's not just about dynamics with the ocean component, it's also about visuals, and it offers an extensive set of visualization tools. It allows you to set everything that is related to boats and vessels moving into water. So you can define the wake of your ships as it move about, the splash of effect of when you're lowering equipment in water. You can also simulate the visuals of a propeller, so that is a backwash that is connected to its speed, and if you stop, it's going to stop the backwash effect as well. And because Vortex Studio is used in the defense industry, there's also tools to simulate a rotor, such as a helicopter propeller on the surface of the ocean. So this is a graphics effect only, but it's nice if you're doing scenarios that involves other equipment that interacts with your ocean surface. And finally, there's a few specialized tools that allow you to really fine-tune your environment, such as the buoy tool. Allows you to automatically connect a visual object with the surface of the sea. So you can see these buoys are bobbing about, and it's a lot more efficient on the processing side. And what's nice is you can also use this to track the height of water at a specific point, and there's a lot of uses for this as well when you want to power some scripts that are related to your ship, for example. We're also going to look in the live demonstration at decals, so that allows you to visualize elements on the water surface, such as liquids, other liquids. So you could simulate an oil spill, for example, on the surface of the water, and it would be efficiently tracked on the surface of the water. And finally, because it's important for vessel training, we also have custom cloud conditions that allow you to set the types of clouds, the density connected to the wind speed. And again, when we're talking about maritime environment, obviously that's going to be key components of understanding meteorological phenomenon. And what's great is that you can tie this to the wind speed that's also affecting the surface of your ocean. So the last part of features of the ocean component is related to subsea environment simulation, and these are really to power subsea equipment or visuals. And the first one is the thruster. Now the thruster allows you to simulate propellers such as the one you see on this ROV here. So it's going to connect these to and transform their rotation to thrust using RPM to force table. And of course, also underwater silt. That's a big part of learning how to operate in an undersea environment. So you can control the types of silt using textures. You can also change its movement speed, size, density. You have a lot of control over that. So we're going to jump into it. I'm going to pass back the control to Marc-Alexandre, who's going to show us different features using the offshore sample included with Vortex Studio. Marc-Alexandre?
Thank you, GP. So to do this demonstration, what I've done is that I've opened a new empty scene document. So you can see the Vortex Studio interface with the toolbox up here. So first thing we're going to do, we're going to access the marine category, and then we see all the extensions that are available for marine. So if you scroll down to the bottom of the list, we've got the ocean component and the ocean with only the graphics with no dynamics. So in this case, I want to show you the ocean. So I'm going to double click on it. I could also drag it, and this is going to create an ocean automatically in the scene. So it's interesting, but I like to see what I'm doing. So I'm also going to go into the environment section and add a sky to the section, and then we're just going to put in some fog just to make it nicer. There we go. So now I've added an ocean to my scene, and I press play, and as you can see, the ocean is simulated immediately. So it's that easy. So of course you have a lot of control over the ocean itself. If you go look into ocean dynamics, so in the input section, we're supporting multiple quality levels: Tessendorf, Pearson Moscovitz, John Swap. Look in the documentation, they explain the advantage and computing cost of each quality level. You can set up the sea level and the sea depth, the normal of the sea floor. So if you're using a terrain object, such as a terrain from file here, to create a sea floor, you can adjust using this. The sea scale type, we're supporting manual, Douglas, and Beaufort. I like to use Beaufort. I used to sail when I was younger, so I'm familiar with that one. So you can see that this is an input, so it's done at real time. So you can just keep on scrolling, and you can attach this to a script and modify the appearance of the ocean in real time. Let's go back to a 4. You can set up the wind direction, the sea current velocity, and the sea current direction. So these are useful if you're doing ROV operation or if you need the boats to drift during an operation. There's a couple of other input that you can set up. Wakes. If you look into the okay, I'm being told that there's a issue with the screen. Hopefully, you can see what I'm doing right now. So I'll just keep talking about the various parameter in the property panel. So you can set up wakes model with your ships, and you can also set up swells for a longer wave that occupy the entire surface of the ocean. There is also a what we call the advanced parameter category. So you can set up the sampling resolution and the water density just like you could in the fluid surface. In the very advanced category, you can set up the sampling, adjust the grids that's used to calculate the waves, the swell, the phase effect, and we're going to add more parameter into that section where you can have even deeper control over the ocean objects, and that's for the ocean dynamic. Under ocean dynamic, as a child object, you've got something that's called ocean graphics, and ocean graphics contain the extension for the silt particle generator as well as the silt material and the silt texture. And from that graphic object, you can control whether the water is visible or not. You can control the distance of the underwater fog. So again, this is an input, so you can tie it to a script that goes with your depth, for example. So if you're running operation with an ROV, you can adjust the visibility distance underwater based on the depth of your ROV. You can also adjust the underwater color for the fog and the refraction color, the distance of the horizon, whether we're using an underwater fog or not. So if we're not using it, it changes the color of the water. There's also an input for reflection. Now what reflection does is that it allows you to control whether objects on the surface of the ocean are going to reflect on it. So it's very costly in terms of computing power. However, it adds a lot of realism to a scene. There's 4 controls for the reflection. The first one being quality, so you can drop the quality level to require less computing power. You can also adjust the height of the reflection compared to the water. You can adjust the reflection intensity, so as you see here, when I adjust it, it changes how the sky reflects in the ocean, and you can also change the planar intensity of the reflection. Now, by using all of these inputs together, you can control the appearance of the ocean based on the weather pattern that are above. So if you're doing a scene that takes place during a storm, for example, obviously the reflection is not going to be the same with the foamy water, the cloud cover, and so on. So you have full control over that. You also, in the parameter, have a value for the reflection frequency. So just like a mirror or the shadows, you can adjust how many frames are skipped when calculating the reflection. So again, this allows you to maximize the visual appearance while depending on the available computing power. And lastly, there's also an advanced parameter section, obviously, that tells you the grid dimension that's used to generate the waves and the swells. And again, adjusting this, you can maximize your appearance versus computing power. I'm not going to show the silt for now because it's we don't have an ROV setup, but you can look into the Vortex sample and go into the offshore scene and play with the ROV, and you'll be able to see the silt particle in action. I just want to show you real rapidly some of the extension. So we're going to put a decal on the surface of the water, but first I need to get a texture into the there we go. So I decided to use the CMLab logo, so that's going to be quite visible. So we've got the CMLab logo here, and we're going to add a decal extension here. So the decal extension has a local transform and a parent transform, so you can attach it via a script or a connection to another object. So that's very useful when you need to place the decal very accurately on the surface of the water. You can control the transparency and the UV offset as well. And there's a section called animation that allows you to animate the decal, and I'm going to show this in a couple of seconds. So I select my texture here, and now I've got my little CM Lab logo that's hanging on the surface of the water, and as you can see, it's following the surface movement of the water. In the parameter, you can set it as infinite, so for certain effect is very useful. And you can also activate additive blending, which is going to add the color value of the texture chosen with that of the ocean underneath. So as I mentioned, we have a section for alpha, UV, and scale. These allow you to do some animation. So we're going to create some field here. So I'm going to activate that. So for the alpha, the initial value is going to be 1, so fully present. The end value is going to be 0, transparent. And then I'm going to give it some time to play, and I'm going to make sure that it plays. And you have a control here that you can put on the connection. So again, you can use it with a script to fully control the appearance of your decal on the water. So here my initial value is going to be 1, and then the final value is going to be 15, for example. And now I've set it to play, and once we play the animation, you can see that my decal is growing on the surface of the water and is getting more and more transparent. So you can do some really nice fade out effect with this. You can also add an extension that's called the splash, and what the splash does, it allows you to chain multiple decals to do very complex animation and also control the location of those decals. So with using a splash, you can, if you have objects falling into the water, you can create very complex splashing effect on the surface of the water itself. Let's just remove our decal, and we're going to take a quick look at the rotor wash. So the rotor wash is, as its name say, mostly used for helicopters effect on the surface. Now, Vortex Studio doesn't support aircrafts or helicopter, but if you're doing something like an offshore simulation, an offshore platform, you've got an helicopter coming in to the platform to deliver some stuff, is going to create disturbance in the water. You don't have to set up a decal or animate it. You just drop a rotor wash in it, and then the computer will take care of the effect by itself. It's got a local transform and a parent transform. You can attach it to something, so you can have an animated model of an helicopter just swooping in, create this water surface interaction effect with the rotor wash extension, and you have full control over it. So we can adjust the velocity, we can change the direction of the water blast, and so on. And we can obviously remove some of the spray effect or remove it altogether. So it's very useful for that. So let's remove the rotor wash, and we're going to go quickly to the meat of the presentation, which is the ship. So we've got a very nice ship model that comes from the Vortex Studio sample. I just want to show you a few things. Now, in the ship hull, we've I mentioned earlier that we could use multiple collision geometries for the ship. So in this case, we've got a contact hull and a fluid hull. Now, the contact hull is taking care of the collision, so it's fairly squarish. It doesn't have a lot of detail. And the fluid hull is doesn't collide with anything, but it's very detailed, and it's used to calculate proper water interaction. So you can see the moiré effect because there's so many triangles in that collision geometry to make sure that we're getting the correct fluid interaction with the surface of the water. We've also added a few things in the ship, so a propeller effect, a propeller thruster. So to model the screw of the ship, we've put an attachment point where the screw is, and then we've attached a propeller thruster. There's the RPM to thrust mapping table in place, and it's putting force vector here. If you have a steerable thruster, obviously you can change the angular velocity, and the vector can move as well, so you can reproduce that directional thruster vane if you have one on your vessel. We've also put in a what's called an imposter. That's the red box that you see here. What the imposter does is that it cuts the ocean volume and doesn't draw water in it. So it's useful for a ship hold, for example, because the water ocean plane is infinite. So if you have a ship hold without an imposter, you're going to see water inside the ship. So if you're doing port operation, for example, where you're unloading a ship, you're going to put an imposter inside the hold to make sure that there's no water present into it. And we've also added at the front of the ship an attachment point here to make sure that we can put in a wake and the water interaction effects. So we've also put in a script that uses a buoy extension to calculate the distance with the surface of the water, and this allows us to have a particle emitter that stays connected to the bow of the ship and interacts to simulate the interaction of the ocean with the ship's bow here. So let's see what it does in action. So I go back to my scene here, and I go back to basics, insert a mechanism. So I'm going to insert the ship here, and I'm going to drop it inside the water like this. There we go. And now I'm just going to simulate. And you can see that the ship is now floating into the surface of the water. So if we go back to our ocean dynamic and we make this a little more active, you're going to see that the ship is actually following the wave. So you can see that it's moving following the wave. Now, if we want to have the ship moving, we have a VHL setup. So I'm going to put some RPM inside the motor, and then the ship is going to start moving. So let's get the water back down to a more effect. So you can see that the ship wake that we've put in place create a stern wave behind the ship. You can see the propeller effect here that's disturbing the water based on the RPM of the ship. And at the front, we've got our particle emitter that's driven by the script and the buoy extension to create the proper water splash effect that's created by the interaction of the bow of the ship with the water. So let's just turn the hour a bit so we can see the ship better. There we go. So you can get some really nice water effect if you're willing to put in the time to code these extensions. And one other thing we want to do in the future is to start automating more and more of these interactions so we have less work to do and you can get your maritime simulation done faster. Back to you, GP.
Thank you, Marc-Alexandre. That was a very good walkthrough of not just the dynamics portion, but the visuals portion of the ocean component. And really, I think it emphasizes the point that Vortex Studio is a complete platform. It's not just about creating a realistic behavior for the equipment. It's about immersing users, and having that entire toolkit in there means that you don't have to always switch between tools, applications, or again, as I mentioned earlier, start from scratch when you have new requirements coming in. And I guess that's a bit where you can see something such as the propeller wash coming in, is that a lot of the time when you're working on offshore scene, you're going to want to immerse users in there. And you're not necessarily wanting to simulate an actual helicopter, but you want people to feel like they're on a normal workday and they have to perform in there. So I find that part pretty interesting. Now, before we move on to questions, and we have a few that came in already, I just want to start about how you can get started with Vortex Studio for maritime simulation. And obviously, today we spoke about some samples that are included with the product. The first one is the maritime ROV deployment scenario, from which we took the assets such as the Norman Kraken. The entire sample includes an extensive underwater portion, and I really recommend you have a look at the samples starting guide to learn how the underwater components are configured themselves. That could be a whole other topic, and be warned, it is a fairly big sample. It's a big scene, so you will want to run this on a desktop computer, or take the asset and, just as Marc-Alexandre did, kind of recreate it and optimize it for what you're trying to test. And we're going to send a copy of the short demo we did for the fluid surface. Again, this is a more approachable feature. It's a great way to get started as well with rigid body hydrodynamics in Vortex Studio. Now, if you have downloaded the latest version of Vortex Studio online, you have a Vortex Studio account, and that gives you access to all of Vortex Studio's documentation. And again, this is really a great place to go and learn more about specific extensions when you're trying to achieve a specific effect, because we have extensive information on each of these extensions, each of these features we've spoken about today. And you could really go and spend hours in there looking at all the different options you have to create some very advanced effects. And finally, I invite you to join us on our Vortex Studio forums. We're going to be posting today's webinar on there, and we'd love to hear your feedback, your questions as well. And if you have questions about specific features, well, our staff is actively on the forums, and we'll be happy to help you explain anything that they can help with in terms of how to use certain features, and even ideas and some tips and tricks that we have picked up over the course of our own projects. Now, you need an active CM Labs account, the same one that you need to access your Vortex Studio online profile, but once you're set up, you can go in there and start posting away. And finally, I invite you to keep track of the Vortex Studio blog at cmlabs.com/blog. It's also where you it's also where we post the articles that you see on the Vortex Studio editor's homepage. We do weekly articles on new releases, upcoming features, tips and tricks and industry trends, and webinars such as today. So that's going to be a great place to keep an eye out for the next webinar we're going to have in the Vortex Studio University series. So that is going to conclude today's presentation. Now we're going to move on to the live Q&A. If anybody is leaving us, I would like to thank you for joining us today for the webinar, and we hope you found the presentation informative and it gave you a better idea on how to get started with Vortex Studio. Again, we will send a copy of this webinar recorded after today's presentation, probably this afternoon or early tomorrow morning. If you have any questions, you can reach us at webinars@cmlabs.com, and we'll be happy to get back to you. So, Marc-Alexandre, I'm going to get started with the first question that we have, and it pertains to simulating rivers, I guess, and maybe that's going to be a bit more tied to the fluid surface extension. Now, we've shown how you could simulate directional flow. Is it possible to simulate a river's current?
Well, obviously what you can do is use a script to change the current value of the fluid surface depending on where you are in the on the river side. For the visual appearance, right now what you can do is it's possible to animate the texture that would be on the water surface. Of course, there won't be any interaction such as splash. Splash you would have to do with a particle generator, and the animation again would have to be directed by a script if the river changes direction. Eventually, we'll have flow material. Right now, we don't, but it's something that you can do fairly easily.
Thank you. Now we have a question if we go back to a maritime environment, and it's related to the propeller backwash effect. One of our attendees asks us if it is a surface texture that is animated as a vessel move, or if it will actually have a visual effect underwater as well. So is it just painted on a surface, or is it movement in the water column?
At this time, the propeller backwash is a decal that's applied, an animated decal that's applied to the back of the ship on the surface of the ocean. If you require for your simulation to have underwater effect as well, so for example, you have an ROV that's coming up within 1 or 2 meters underwater at the back of the ship, and you want to represent the cavitation and the bubbles created by the screw, the propeller effect is not the right tool for that, because you're only going to have the surface effects. However, there is always a possibility to have a script that ties in the propeller thruster as well as a particle emitter, and that would create the bubble effect underwater that you would need for that. I would see it as one possibility. Obviously, you could also use the SDK to code your own custom extension, but which is the basic tool available in the application already. I think you can do a pretty convincing underwater effect as well.
Thank you. All right, next question is related to, I guess we're going to go back to a bit the basics of what we simulate. We mentioned that we simulate the effect of water on objects. Now, do we simulate underwater pressure with either of what we've shown today?
No, water pressure is not a value that's used in the simulation itself. So if you have an ROV that's like 3,000 meter underwater, the water pressure is not going to be taken into account in the simulation itself. If you need it to be taken into account, you can always add a script to the simulation, which is going to create whatever effect that you need in terms of pressure. So if you have things that are affected by the pressure as you go down, like mobility is impaired or buoyancies change, you can always use the script to tie in the current depth of the object with its behavior, but it's not something that's actually simulated.
Thank you. Now, as usual, we're seeing questions related to specific projects. If you're joining us for the first time at the Vortex University webinar, don't hesitate. If you're working on a specific type of projects and you have questions, send them our way. We will take them privately. We're not just doing public questions. So we encourage any and all questions. Some of them might have to be taken offline when it gets very complex, but do go ahead and send them our way. All right, so we have another question here, and it's related to the visual aspect of what we've shown today, specifically surface reflection. Now, you did mention that this takes a good amount of computing power, and depending on your system, sometimes it might be more power than is available. One of our editors asked, is it possible to use an approach with decals based on the environment to simulate, to approximate the surface reflection?
So right now, that's not a feature that's inside the product. It's something that is in R&D, so based on light probes, and it's also going to be used for surface effect like windows reflection, color splashing, and so on. However, for reflection, as you can see during the demo, there's a lot of parameters that are accessible that you can tune in order to match the computing power that you are able to dedicate to the reflection effect to make sure that it fits with your training need and the performance requirement.
Thank you, Marc-Alexandre. That appears to wrap it up for the question that we have today. So I believe we're going to actually, we have some more coming in. Again, we're going back to the propeller backwash effect. Let us look into it. All right, so we're going to a pretty detailed question here that is related again to the propeller backwash. So with the example of OSV maneuvering an offshore installation with short bursts of propulsions that are often applied to keep the station in its location, is it possible to get visual feedback cues on this, or does it require movement at the source of the truss for it to appear?
So right now what you have is the propeller effect is tied in with the velocity of the propulsion effect. So yeah, you're going to have some burst. There are limitations. So the current propeller effect doesn't curve in the water. So if you have an orientable thruster, it's not going to do the proper arc. If you want to have a bubbling effect at the surface to show that the propeller is working but the ship is not moving, you can simulate that with a particle emitter on the surface of the water, again tied with the motion of the ship and the velocity of the screw with a script. This is something that's in R&D right now that we're working with the Maritime Institute. They had the same concern as you did, and it's something that we want to improve in the future.
Thank you, Marc-Alexandre. All right, so we will remain on the line for some more time to answer a few private questions, and we encourage anybody with further questions, send them our way. But at this point, we will end the public question period. If you are leaving us, again, thank you so much for joining us today, and we hope we will see you at our next Vortex University webinar. And we'll, if you have any requests for topics, please do send them our way at webinars@cmlabs.com. We'll be happy to fit those into the schedule. And Marc-Alexandre, again, thank you for today's presentation.
No problem. And if you have any question, please get in touch with us for more information.